Hi all, and welcome to this third module of the course. In this first video we are going to introduce Sparkle, a query language for the semantic web and linked data, and in general for any RDF-based data or model. In traditional relational database applications we have SQL as the language for retrieving and managing our data. In the RDF world we have Sparkle as the most used language for querying data based on the different models that are built upon RDF, such as, for example, RDF or OWL, or RDFS, for example. As the standard on the community, it is supported by most of the initiatives and solutions available nowadays, such as, for example, the Gina or Sesame Java APIs, or services such as Virtuoso, Stardog, Forestore, or Fuseki. So let's say that we want to ask some question about this simple graph, this RDF graph, in which we have three different persons, Oscar, Asun, and Raul, related to each other with the has-colleague property. And for some of them, we have additional properties, such as, for example, the name of Oscar or the homepage of Asun. If we want to ask, for example, about the person that have Raul as a colleague, what we will ask is, we will build a pattern in which Raul is the object here, the property is has colleague, and we'll leave the subject, in this case, open. This is what we are asking for. If we try to match this triple pattern against our graph, what we will obtain is that the result is Asun. That is, the only subject that meets our requirements is here. What if we want to ask about the relationships that exist between, for example, Oscar and Asun? What we are asking is triple patterns that has Oscar as the subject, Asun as the object, and we leave the property open. That's the variable we are asking for. Again, if we try to match this pattern against our data, what we will obtain is that the only property that meets this requirement is the has-colleague property that exists between Oscar and Asun. We can do more complex queries. On the previous example, we were using just one triple as the pattern. Here, if we want to ask about the web page of Oscar colleagues, what we are asking is triples that has Oscar as the subject again, the has-colleague property related to any object. I don't care about the object in this case, but what I want is this object to has the property has homepage to a certain value. That's what we are asking for. In this case, if we try to match this pattern against our graph, this is what we will obtain. We will obtain oegupn.net because that's the only pattern that meets what we were asking for. So this is how this pattern, this is how a Sparkle query looks like when we put it on code. We have different parts which we will introduce later on the coming video. First, we have the prefix, which allows us to define the vocabularies that we are going to use in our query. This is the same as we saw on the previous video, on the previous module about RDF, about defining vocabularies and using these prefixes as a short form for writing them. This saves time, of course, when typing, and also prevent us for making or committing errors in our code. Then we have the constructor. In this case, we have select, which is the most popular one, the most used one, in which we are specifying that we want to obtain, in this case, the name and the website. Those are the variables that we want to obtain, information that we want to retrieve. We have the from clause, in which we specify the data source, the origin of our data, the set of triples that we are querying, in this case, this file over here. And finally, the where clause, in which we specify the pattern itself. Here is where we say what we want to retrieve. So in this case, we are saying that we want a person, a given person that has a web log. We want also this same person to have a FOAF name, and that the website related to that person must be a FOAF document. Here we see again, as in the previous module, that we are using A as a short form of RDF type. It's a way of saying RDF type without having to type it. In the following videos, we will introduce in detail each of these components and see how to build queries using different features of Sparkle. For the time being, let's just keep in mind how these queries are written. So, Sparkle is a query language, but also a protocol. That is, it's a language that defines how to write queries to retrieve data in RDF, but it is also a protocol that allow us to execute queries remotely. So we have a transport protocol to invoke the service, to invoke a Sparkle service and obtain the data, which we can obtain in different output formats. This allows us as well to describe the service using web services technologies. When we execute our queries, we execute them against a Sparkle endpoint. That is either an online or a local connection point implementing the Sparkle protocol for RDF specification. That is the point in which we are using to run our queries against. In this list, in these two links, we have a list of Sparkle endpoints that are available for anyone to execute queries, in which we will find different types of endpoints. We have general ones, such as, for example, the Wikipedia endpoint, in which we have information from Wikipedia annotated using RDF, or specific ones, such as, for example, the Open Data Portal from Aragon, or the portal of open data from the Biblioteca Nacional, the National Library here in Spain. We have other for water quality, for example, in UK, or the general European data portal, which has a Sparkle endpoint for running queries. Go ahead and give them a try, as most of them contain sample queries that you can execute straight just to see which data is contained on each of them. In the following video, we will see how to write different types of queries, going from simple ones to more complex ones, exploiting the many capabilities of the Sparkle query language.